Alright everyone, so this is yet another video with Chem Society. I believe we have a couple previous ones, so if you'd like to, you can check those out. I've lost track of how many now. I think it's like 3, 4, something like that. You can probably see them on the side of the screen. But anyway, today I'm going to be talking a little bit about one or two of our reactions that we have involving hydrogen peroxide. Hydrogen peroxide was, while one of the main components of our reactions, isn't the primary focus of it. We're looking more at catalysts. So for our first one, it's a demonstration called elephant toothpaste. So what it is you add concentrated hydrogen peroxide to the bottom of, well, pretty much any container. We do a large graduated cylinder for us. We don't want to generate too much pressure because I'm the one who cleans up all these demos, and it just gets tiring after a while to clean up a bunch of suds from the ceiling. But anyway, this is also commonly done in like Erlenmeyer flasks or volumetric flasks. And to that hydrogen peroxide, what's added is, well, we use a yeast. So like you go to the store and you get, yeast for bread making. We use yeast for this. It works the same. Also, sodium or potassium iodide are commonly used. They cost a bit more than yeast does, and they also generate a bit more vigorous of a reaction than what our yeast does. However, again, it's me cleaning it up, so I don't want to have to scrub suds off the ceiling. Anyway, so you add them together, and what happens is the hydrogen peroxide loses one of its oxygens. So the structure for hydrogen peroxide is it's two oxygens bounded together, and then it has two hydrogens coming off. And so the yeast catalyzes the reaction to lose one of those oxygens, and then it's just forming good old water. But that oxygen, it's free floating, and it joins up with another oxygen coming from another peroxide, and you've got O2 gas. And so especially since it's catalyzed, it's a lot quicker. That's the point of a catalyst. You get your reaction to go a lot faster. And you get these bubbles because we've also added dish soap, and for the green color we've added some food coloring to our solutions. And you can see it starts to foam up and starts to foam over as the dish soap starts to capture this oxygen. After a little bit, we take a smoldering splint, and we're able to stick it into these bubbles. Not right away because the bubbles are too small. There's not enough oxygen for all the water that's in those bubbles. But after a little while, some of the bubbles start to combine. We're able to stick a burning splint in there, and you can see it flame up nicely, which is a pretty neat thing to see. The second one that I'm going to talk about that involves hydrogen peroxide is it's called a pink catalyst. It's a cobalt chloride solution, and as you can hopefully see, it's a very nice pink color. We're going to add it to a solution of sodium tartrate, which is C4H4O6 2-. So for us, it's sodium tartrate, which means that there's two sodium atoms giving a plus charge to the tartrate anion. And so we heat that up. And so it's on a hot plate, as you can tell. We warm it up a little bit so that the reaction takes place, and then we pour in some hydrogen peroxide, which you just heard me mention. And as you can see, there's no reaction that's taking place yet. The solution's still nice and clear. There's no bubbles or anything evolving out, and it's just sitting there. And to that, then, we add 15 milliliters of our cobalt chloride solution. And what happens is it's a cobalt chloride solution, so it's nice pink. We add it in, and the color change is pretty quick. It turns kind of a sickly greenish brown color because it's turning green, and the pink of the catalyst are kind of mixing strangely. And yeah, and then you give it a little bit of time for it to start to react, and then you can see a bunch of bubbles start to evolve. And the color goes the whole way to green, and as these bubbles are evolving, it's carbon dioxide that's being produced. The exact formula is actually, it was on that poster right before the video started, or it should have been. The entire formula involves 5 units of hydrogen peroxide plus 1 unit of our tartrate, and it forms 4 units of carbon dioxide, 6 units of water, and 2 units of the hydroxy anion. which our sodium will stabilize, so it'll form sodium hydroxide, which if you were watching one of our other demos, we made a pretty interesting way of making our sodium hydroxide earlier. And then once our reaction finishes, the bubbles start to slow down, and it's pretty quick that our catalyst comes back out. The point of a catalyst is it goes in at the beginning, it speeds up the reaction, and then you get it back out at the very end. So our solution turns back to its original pink color, and if we had more of our products, you would be able to see it react again, which we didn't do for this one, but it's still pretty neat. Alright, so thank you for watching the video, and I hope you enjoyed it. Please watch some of our other ones.
Sucks to suck.
Hey, the chloroform's coming back out for you people.